Right, in this video we're going to continue looking at factorising quadratics, and we're going to look at factorising where a is not equal to 0. I mean 1. But obviously 0 as well, because if it was 0 then this wouldn't be a quadratic, it would then be linear. Anyway, now let's look at some examples. So again, it's going to factorise into 2 brackets. And the goal is that when we multiply these out, we get this original expression back. So I want to get a 2x squared. So how I'm going to get that is I'm going to put a 2x here, and an x here. And then I want to make 2 numbers that will multiply to make -3 and also add to make this -5. But the thing that's different here is whatever I put here, multiplying by 2x. Notice how if I put -3 here and multiply that by 2x, that gives us -6x. And if I put the +1 here, that gives us x. And then the -6x and the x make -5x. And because that's a plus and that's a minus, when I multiply these 2 numbers, that gives us the -3. And the 2x and the x give us a the 2x squared. Next one, we've got a similar sort of problem. It's going to have to be 2y and a y. And again, it's going to be a plus and a minus. Let's see, because that's the that's minus, we want to make the biggest number a minus. So I'm going to put a -5 here. And that'll give us -5y. And then, let's see if I put, how about a plus here, 2. Then that'll give us 4y minus 5y, which will give us a -y. And when I multiply these, that'll give us the -10. And of course these will give us a 2y squared. Now this one here is a bit tricky. We've got a negative x squared and we don't really like that too much. So what I'm going to do here is I'm going to do something quite clever. And instead of taking out 5 as a factor, I'm going to take out -5. And then that'll make, then we can make this a plus. So if we take -5 out as a factor, we're going to be left with 4x squared minus 7x minus 15. And then there's going to be one more step, which will be obviously to factorise this expression here. Notice this time we've got 2 possibilities. To make the 4x squared, we've got a 1 and a 4, or 2 and 2. Let's see which one we're going to use. We're going to have to. And then for the 15, we've got 2 possibilities. We've got 1 and 15, 3 and 5. But also I want them to add to make this -7. So let's see which ones we're going to use. We've got a 12 here and a 5. That makes a good difference. That'll make a difference of 7. I like that, so we're going to go ahead with that one. So I'm going to put 4x and x. And I want my biggest one here to be the minus. So what I'm going to do is I'm going to put my minus here. That's minus 3, then I multiply that and that makes minus 12. And then if I add this 5 here, that'll give us a minus 7x. Because here I've got minus 12x, here I've got 5x. Then if I add 5x to minus 12x, that gives us the minus 7x. And then this here gives us the minus 15. This here gives us the 4x squared. Then we'll get back to this. And then if we multiply all this by minus 5, we'll end up with this original expression here. Now, this one here is also a bit tricky. I'm going to let y equal x squared. Maybe I should rub this out. Read this example and write it down if you need to. I'm going to have to rub it out for some more room. So if we let y equal x squared, then I've got this expression 2y squared plus 14y plus 24. And then we can factorise this. First of all, we'll take 2 out as a factor actually. And this will be a lot easier. Sorry, I meant to just put one bracket. And then this is actually a nice easy one, we don't even have to do much. This actually simplifies to a nice easy one where there's not really much problem at all. So that's going to be a 4, that's going to be a 3. And you'll see that that works, and then we'll substitute back to what they were originally. That's y is x squared, so we'll put x squared everywhere, we'll say y. And that'll be the solution to the original problem, because if you put y, if it was on an exam, people who are reading wouldn't know what y is if you just make it up and you don't tell them this. So it's best to go back. Now we're going to look at an application to factorising really quick, because people don't always know what algebra is useful for. So here's the problem. I want to show that the sum of 5 consecutive integers is always a multiple of 5. So if we choose a random number, we could say that this random number is n. So then the number after that would be n plus 1. So we've got 5 numbers here, so let's put 1, 2, 3, 4, 5. Then the next one after that would obviously be n plus 2, n plus 3, and n plus 4. See, this is just going up by 1 each time, because each number's after the one before it. Because they're consecutive integers, and n's just to represent that it could actually be any number we're starting from. So it's the sum of them, so what we'll do is we'll actually add all of these up. And we're going to get 5n. We're going to get plus 5n plus 10. And then we'll add these up. And then the way that we can show it's always an integer, that it's always a multiple of 5, is, in fact, we can factor a 5 out of this expression, which is quite nice, because if we can factor the 5 out of here like that, that means 5 itself is a factor of this expression for whatever value n is. So that proves that the sum of any 5 consecutive integers is a multiple of 5. And you can actually check that, and you'll see if you choose any 5, you'll see that the number you get will be a multiple of 5. I just want to say that this really quickly that this wasn't a quadratic one. I just wanted to show you an application for it, because it's interesting to know what these things are used for.